Welcome everyone, I am the Geeky Gamer Science Teacher, here to help you with 1.1, Atomic Structure, the Building Blocks of Matter. Alright, let's jump right in. Here's our game plan for today. First, we're going to cover what atoms actually are, the ultimate building blocks. Then, we'll meet the crew of particles that make them up. After that, we'll zoom right into the atom's core, figure out how to read an element's stats, and then, the fun part, we'll actually build an atom together. Let's do this. So, first up, the ultimate building blocks. And this is a huge idea. I mean, everything. The chair you're sitting on, the phone in your hand, you, me, everything. It's all made of these ridiculously tiny things called atoms. I love this analogy because it's just so perfect. Think about it. You can grab a handful of Legos and build literally anything you can dream up, right? A car, a castle. Well, the universe is basically the ultimate Lego master, and its bricks are atoms. They are the fundamental pieces used to build everything that exists. So what does that actually mean? It means an atom is the absolute smallest piece of something you can have that is still that something. Like if you had a pure gold coin and you could somehow cut it in half, and in half again and again, you'd eventually get down to one single atom of gold. If you tried to get that, well, it wouldn't be gold anymore. That one little atom is what holds the identity of gold. But wait, plot twist, the atom isn't the end of the story. It's not just one solid little speck. Nope. It's got its own team of even smaller particles inside. So let's meet the atomic crew. Okay, so you've got three main players in this little atomic party. You have the proton, which has a positive charge, the neutron, which has a neutral charge. See? Easy to remember. Both of those guys hang out together right in the center, in a place called the nucleus. And then you have the electron with a negative charge, and it's the energetic one just zipping around the outside. Let's talk about the proton first, because this particle is the VIP. It's the boss. Why? Because the number of protons an atom has is what gives it its identity. An atom with one proton is always hydrogen. An atom with 6 protons is always carbon. It's non-negotiable, like a unique barcode that tells you exactly what you're looking at. Alright, next up is the neutron, the peacekeeper of the atom. Okay, think about this for a second. The nucleus is packed with all these protons, which are all positively charged. And what do particles with the same charge do? They repel. They want to fly away from each other. The neutron, with its neutral charge, slides in between them and acts like a buffer, like a kind of nuclear glue that holds the whole thing together. Pretty important job. And finally, we have the electron. These are the super tiny, negatively charged particles that are in constant motion, orbiting way out from the nucleus. And when I say tiny, I mean it. To give you some scale, if the nucleus was the size of a marble sitting in the middle of a giant football stadium, the electrons would be like little flies buzzing around way up in the stands. They have almost no mass, but that negative charge is absolutely crucial for balancing the atom. Okay, so let's zoom in on that marble in the middle of our imaginary stadium. It's time to get a closer look at the atom's dense, heavy core, the nucleus. So as we said, the nucleus has two main residents, protons and neutrons. They live in the same neighborhood, but they have very different day jobs. The proton's whole purpose is to define the element with its positive charge. The neutron's job is to use its neutral charge to be the stabilizer and keep the whole nucleus from falling apart. And this really brings us back to that super important question. Seriously, pause and think about it. If you've ever tried to push the positive ends of two magnets together, you know they push apart with a lot of force. So why doesn't the nucleus, which is jam-packed with positive protons, just explode? And the answer, once again, is our humble hero, the neutron. They are absolutely essential. By getting in between all those protons, they create just enough space to let this other thing called the strong nuclear force take over and hold everything together. Without neutrons, the nucleus of pretty much everything besides hydrogen just wouldn't be able to exist. Awesome. So now that we know all the players on the team, let's learn how to read their stats, just like you would for a character in a video game. We're going to talk about the atomic number and the mass number. First, and this is the most important stat on the entire sheet, is the atomic number. We usually represent it with the letter Z, and it is simply the number of protons. That's it. This one number is the element's unique, unchangeable fingerprint that defines what it is. For example, you always see the number 6 with carbon. That's its atomic number. That means every single carbon atom in the entire universe has exactly 6 protons. If you found an atom with 7 protons, it's not a weird version of carbon, it's nitrogen. The proton number is everything. The next stat is the mass number, which we represent with the letter A. Now this one is just simple addition. Since those electrons are so light they barely count, we find the atom's mass by just looking at the heavy particles in the nucleus. So the mass number is just the number of protons plus the number of neutrons. Simple as that. Let's go back to our buddy carbon. We know its atomic number is 6, so it has 6 protons. A really common version of carbon, what we call an isotope, also has 6 neutrons. So we just add them up. 6 protons plus 6 neutrons gives us a mass number of 12. And that is exactly why we call this version carbon-12. Makes sense, right? All right, we've got the theory down, we know the rules. Now it's time for the really fun part. Let's apply everything we've just learned and build an atom from scratch by drawing a simple diagram called a Bohr model. Okay, we're going to draw a lithium atom. First step is always to check the periodic table. Lithium has an atomic number of 3, so we know right away it's got 3 protons. We'll use a version that also has 4 neutrons. So step 1, draw a circle for your nucleus, and inside just write 3p plus and 4n0. Done. Step 2, figure out the electrons. For a neutral atom, the positive protons and negative electrons have to be balanced. So 3 protons means we need 3 electrons. Step 3, draw the first shell or circle around the nucleus. Now this first shell is tiny. It can only hold a maximum of 2 electrons, so put 2 little dots on it. Step 4, we still have 1 electron left over, right? So we have to draw a second shell and we place that final electron on it. And there you go. That's a simple model of a neutral lithium atom. Phew! Okay, that was a ton of information. Let's do a quick mission debrief and lock in those key takeaways so you don't forget them. Okay, so here's the absolute must-know info. Atoms are the building blocks of everything. They're made of positive protons, neutral neutrons, and negative electrons. Protons and neutrons are in the nucleus. The atomic number, which is just the number of protons, defines what element it is. The mass number is just protons plus neutrons. And super important, in a neutral atom, the number of protons equals the number of electrons, so the charge is perfectly balanced. And I'll leave you with a final thought to chew on. We said an atom is mostly empty space, right? Like that stadium analogy? Well, if you're made of atoms and the wall is made of atoms and all those atoms are mostly empty space, why can't you just walk right through a wall? The answer has to do with those tiny little electrons, but that's a story for another time. Thank you so much for watching. If you found this video helpful, informative, or entertaining, please give it a like and subscribe. It really helps me so I can make more science content. Also, feel free to comment any questions you might have or requests for future topics. In a world where you can be anything, remember to be kind,